conference for the AI for Good Global Summit. It's going to focus on AI-enabled brain-machine interfaces. If you don't know what that is, we will explain to you during the course of the press conference. But we'll be demonstrating to you exoskeletons, interfaces, technologies that create new prospects to improve the lives of persons with disabilities. You'll see that we have 7 demonstrations for you today, each taking about 5 minutes, leaving some time at the end for questions, but do feel free to ask questions as we go through. There is a roving microphone to help you do that. So I'm going to kind of talk in order of appearance. We have an introduction from the Deputy Secretary General of the ITU, Thomas Lamanauskas, who's just standing here in one moment. Then we'll go straight into demonstrations. So you'll hear at the end of the table first from Mr. Pedro Vasca, who you may have seen yesterday, the CEO of Unbabel. He'll be presenting alongside the VP of Innovation, Paulo, who's wearing a headset. Unbabel Halo combines a non-invasive neural interface with generative AI, transforming patterns of bioelectrical signals into language that users who cannot speak or type will be able to use, people with ALS or in locked-in syndrome, so that they can communicate with their friends and with their families. Next to him, you'll see Dr. Chieko Akasawa, IBM Fellow. She is a leading innovator working in the area of accessibility. Her initial contributions to the field started from Braille digitalization and moved into web accessibility. Since 2010, she is focusing on real-world accessibility to help the visually impaired. Next to me is Mr. Nicolas Simon, founder and chairman at Wondercraft. Wondercraft has created the first natural walking exoskeleton capable of walking around autonomously, and you'll see that today. At the end of the table over here, you'll see the person who's kindly agreed to demonstrate it to us is Charlotte Fairbank. She is a professional wheelchair tennis player, and she will be walking along this area here, so you might need to keep your feet in, and hopefully it's all clear. To my left is David Hirsch, who's the head of the press office, and Cornel Amarai, hopefully I am pronouncing that correctly, CEO of Dot Lumen, who I met yesterday, using technology similar to that in self-driving cars. I'm sure he'll tell you about that. Dot Lumen has developed glasses that allow the blind to see. He may well be asking for one of you to volunteer to test this out, and he describes them, or the company describes them, as a kind of virtual or digital guide dog. So that will be quite exciting for us to see. Next to him on the left is Dr. Jose Del Milan, professor at the University of Texas in Austin, who will demonstrate with his team brain-controlled hand exoskeleton. And his team's just here, where they'll be able to show the intent to move the hand, and they also may well ask for a volunteer from you. And right at the end, you'll see Professor Olivier Roulier, the co-founder and the CEO of Inclusive Brains, and his co-founder, Paul Barbast. They will be demonstrating a multimodal brain-machine interface powered by cognitive AI. And they may well tell you a small anecdote that's got the Twitter storm alive today. Apparently, they tweeted President Macron on stage earlier today, is that correct? And he retweeted it, and that's going quite viral. So I'm sure we'll hear the anecdote as we start today. So just some quick rules of the game. Please ask questions whenever you want, but there is a roaming microphone. There should be time at the end to ask questions. Please can I ask you, when you ask questions, just to raise your hand and identify yourself, your publication, and your name. There are reporters joining by Zoom, so if you're joining by Zoom, you can also ask questions via the chat facility. And a very important point to mention, to my left over there is a lunch for you to take away at the end. So, without any further ado, I'll now hand over to the Deputy. I'm not ITU, no, my name's Chris Cartwright. Thanks for asking. I'll hand over to you now, Thomas, if I may.
Thank you very much, Chris, and welcome everyone to this press conference. Indeed, some of you yesterday saw Luis on the stage. And Luis, around 1.5 years ago, lost the ability to communicate, lost the ability to relate to his loved ones, to his friends, other people. Yesterday, you saw him communicate. Yesterday, you saw him able to respond to the questions, interact with the audience. So this is what these discussions today and solutions today is about these solutions that can people regain the ability to fulfill their purpose in their life and to be part of us, to be part of the society, to be part of this world. So we'll see today different solutions. We'll see brain waves control speech, that similar solution that exactly the solution was yesterday. We'll see exoskeleton. I think we'll see around 7 different solutions here, or exactly 7 solutions here, that will show how technology empowered by AI can help us really live fully fledged lives in the society despite differential abilities in this. So this is also the essence of AI for Good, to bring you not only the discussions, but to bring you real experience. Last year we did that with the 9 humanoid robots. I was told it's the biggest human robot press conference ever, probably still, that we have. And now this year you have these solutions on it to see, to experience, to question, to understand. And we need to understand them. Because, of course, as much as there is a lot of potential, there are also challenges and limitations that we also need to understand. There are ethical considerations that we need to understand how to control, how to govern, how to regulate. But we cannot regulate them well. We cannot talk about them well. We cannot have a conversation about them if we don't experience them, if we don't understand them. And again, so today's press conference is exactly about that, to understand them so that we can question them, we can interrogate them, and we can together build the solutions that will both emphasize their potential and harness it, as well as control the risks that they may create. So with that, really looking forward to great conversations and great demonstrations. So back to you, Chris. Thank you.
Thank you. I should, before Pedro speaks, quickly introduce to his right Andreas Forsland, CEO at Cognixion. He'll be speaking last today and demonstrating Axon R, which is a wearable brain computer that combines AI with augmented reality and will be demonstrated for the first time today in a live public demonstration. But with that, I'll hand over to Pedro, if I may.
Fantastic, thank you. So we started Project Halo inside of Unbabel a bit as a side project initially, and it was really to explore how we envisioned the future of AI augmented cognition. And what we were trying to do was to create a non-invasive way to enable what we call the silent communication channel. Initially, we explored EEG. There was a lot of noise, and we ended up settling on EMG. When we couple it with an LLM that is trained on the user, what we realized is that we were achieving a rate of communication that, even though it was not sufficient to be consumer grade, it was already sufficient to really start solving problems of real people. And so we started looking at patients with locked-in syndrome, which ALS is one of them. To give you a sense, Stephen Hawking would communicate at roughly about 2 words per minute. With Halo, you can communicate roughly at 15 words per minute. And so that made a significant difference in the life of patients. Yesterday, we demoed live with a live patient, Luis, who was very kind to join. He's been fundamental in the development of the project. Today, unfortunately, we don't have Luis, but we have Paulo that will be playing Luis. And so the plan is, I'm just going to show you how it works, and then I welcome a question from the audience and take questions. Should be simple. So what I have here, you should see on the screen is WhatsApp. I will send a message to Paulo. Paulo is here. Actually, Paulo, perhaps you can stand up. Might be easier. Just so you can see, he's wearing the current version of the BCI device. And so I'll be sending this question to Paulo, assuming, there we go. I'm told that the Wi-Fi is spotty here, so hopefully that will happen. Paulo should be getting the message. And what's happening right now is, as you can see, Paulo has an iPhone, one of the iPhone pieces. So he's getting a verbal interaction with the LLM. So the LLM is basically saying, given what he's been trained on and what he knows about Paulo, he's suggesting what is potentially a few answers that he could select. If the right answer is right there, he can immediately focus on that particular answer and select that to be used. If not, it can further explore the model. So we see here the answer from Paulo. It says it's been fantastic. So the question I asked is, hi Paulo, what do you think of the AI for Good Summit? The answer is, it's been fantastic. Lots of inspiring talks and ideas. Can't wait to discuss our next big AI project. Now, another interesting thing here that we announced yesterday is a partnership with OpenAI, and using their voice LLM enables us to recreate Paulo's voice. Obviously, in the case of Paulo itself, he can speak, but in patients that lost their voice, what we realized is that a lot of times they have their voice recorded either through messages or through audio before. So we're able to take those samples and using the voice LLM, recreate their voices. And so this means that, and I'll play it here. Let's see if we can hear it.
It's been fantastic. Lots of inspiring talks and ideas. Can't wait to discuss our next big AI project.
Right. And so with this, patients are essentially recovering their voice and able to communicate with loved ones. Maybe we can take a question from the audience? And I can type it.
You mentioned your
Oh, no, sorry, I meant like, do you want to send a message to Paulo so that you can, we can do one more message and then we can take questions?
No, I'll do the question
Okay,
later.
later, okay. There's a,
Just a moment, please.
how
Pose your
does
question
it feel-
into the mic.
How does it feel to wear?
To wear that headband on your head.
The headband on your head. There you go. So I will ask this question. And let's see what Paulo answers without speaking. Yeah, one of the things that we've really impressed us is the fluency of the answers, and a lot of that is due to LLMs, right? So that's an interesting example of realistically we're capturing fairly small amount of EMG biosignals, but because of the LLMs can expand that into a full natural language sentence, it really creates a much better interaction.
Please repeat the message. Sorry.
Yes, absolutely. Oh yeah, I wonder if you got too far from the phone.
No, it was
No?
not that.
Okay, let's try the question again. Always great with live demos. One thing actually that, since it's a good point, one thing that we're working on right now is increasing the robustness of the device itself. So we are not commercializing it fully yet, exactly because, I mean, it's already frustrating for, oh, there we go. The answer is it's pretty cool, feels like I'm part of the future. Let me play the voice.
It's pretty cool. Feels like I'm part of the future.
Yeah, so it works fairly well, but it requires a bit of maintenance, and so it's not quite ready to be mass produced yet. That's the current phase, is really making robust. As you can imagine, it's already frustrating for Paul when there's a glitch, but for an LS patient is particularly frustrating. We've been having a very large amount of requests. Obviously, these are patients in significant distress, and we hope to bring that very soon to the general, well, not the general public, but this particular segment of the population. The plan is to spin off Halo as an individual entity. That should happen in the next 6 months.
So I'm just thinking in terms of time, maybe we could leave some more questions to the end so we can get through, because we have 6 other speakers, if that's okay.
Perfect.
So thank you very much for that. I'll ask if Dr. Chieko Asakawa can now.
Thank you.
Thank you.
Hello. So I'm going to talk about the AI suitcase, but first I have to apologize. This time I couldn't travel with my suitcase robot, so I'm going to try show, by bringing as many parts as possible. So actually, this is a miniature of our AI suitcase. But before introducing it in detail, let me, tell you a quick background. Actually, when I became blind at the age of 14, I faced the mobility challenge because I couldn't go anywhere by myself. After becoming a researcher, I started working on accessibility. And from around 2010 to today, I started working on the mobility challenge. And maybe you may think, why the shape of the suitcase? Please watch him. Sorry, it is just a regular suitcase. But when I'm using that regular suitcase at the airport, I noticed the suitcase hits wall in front of me. Can hit? And then suitcase even fell down in front of me. So I thought it's going to be very, safe. So I thought if we can integrate AI perception controls into the suitcase, it can be my new travel companion. So we are now developing the AI suitcase, and you can see the life-sized suitcase on the poster. So, so suitcase is equipped with several sensors. On the top of the suitcase, there is a LiDAR. I brought the real LiDAR here, and it measures the distance to the surrounding wall and obstacles. And under the LiDAR, there are 3 RGB depth camera. This is one camera. So it is used to detect pedestrians. Because of this camera and the LiDAR, we can do the localization, and we can avoid collisions with obstacles and pedestrians. And inside of the suitcase, on the left, there is a GPU computer, and it does image analysis. And on the right side, there is a computer. It does localization, controls maps, manage user interface via a smartphone. And our handle is very special. It's not just a handle. I brought the sample of a handle. It has various sensors inside of the handle. So when I grip it, it starts moving. It's very simple. And when I release it, it stops. Because there is a touch sensor under the handle. And when turning right, the right side of the handle vibrates. And when turning left, the left side vibrates. And on the top of the handle, there are several buttons, and we can change the moving speed. So it's really simple. And it has been already a while since we started working because suitcase-shaped robots were really new, and it has been really new to lead a person, not autonomous robot. It's a kind of shared autonomous. We have to confirm the safety of a user who will walk next to robots. So. But anyway, now this robot is almost available for large experiments towards a social implementation, and we have been conducted many trial sessions and received many positive feedback from users, and most of everybody said to us that they want us to make it real. So our next challenge is social implementation. So to implement new technologies into society, we need to gain social acceptance. So this kind of conference is very important to show why we need such kind of robot. So this was a great opportunity for me to be here. And but I'm very happy to tell you that we are going to have another opportunity in Japan. So actually, maybe you may agree, Expo is a great opportunity to accelerate the social implementation. And we are going to have Osaka Kansai Expo in 2025. And we have been working for an interactive AI suitcase daily event. And finally, we made it. So just this week in Japan, we announced that AI suitcase is going to be at the Osaka Kansai Expo. We are very sorry I cannot show you today, but please come to Japan and experience it at Osaka Kansai Expo. Thank you very much.
Thank you, Dr. Asakawa. I'll now hand over to Nicolas Simon next to me to do his demonstration, please.
Yeah. So, hello everyone. So I'm Nicolas Simon. I'm the founder of Wondercraft. So we started 12 years ago to build an autonomous exoskeleton that Charlotte will demonstrate to you. So basically, it's legs of a humanoid robot able to carry a human up to 100 kilograms. So there is a lot of sensors, motors, and we compute every millisecond the order to keep the balance and walk.
Hi everyone. So my name is Charlotte Fairbank. I've been Hi, everyone. So as I said, I'm Charlotte Fairbank, and I have been injured for just under 16 years. I've got a complete paraplegia, meaning that I can no longer feel my legs or move my legs at all. So no longer able to walk. Luckily, Wondercraft has helped me in the sense that they have enabled me to be able to walk again. And just before this press conference, we had a demo on the main stage, and it was basically the first time in 16 years that I was walking across a stage. So I'm now going to show you what we did earlier. Thank you. That I can go slightly. Thank you. I'll explain when that's says. I'm just going to stop here. Sorry for those behind me. But so there are different speed modes. This was on the second mode. I can put it slightly faster. There are different modes in the sense that was the walking mode, but there's also a free mode, which enables me to kind of have a bit more freedom within the exoskeleton, be able to move around a little bit. So I'm going to show you that right now. And so as you can see, I can move around a bit more. And it enables me also to go and grab something on the floor, for example. So on the floor or up above, it just gives me a bit more freedom to move around. The way this works, the exoskeleton works, is with, as you can see, a hand remote control, really easy and just super light to hold. And the way we move forward is with this tiny joystick at the end of the hand remote that I just push forward. The exoskeleton also works with a motion sensor, which is behind my back. So when I bent down earlier or when I stood up earlier, the motion sensor kind of sensed what I wanted to do, sensed my movement, sensed my intention, and allowed me to stand up and will allow me to sit back down.
Thank you. That was amazing. Thank you. Well, thank you very much, Charlotte. That was amazing. Thank you. So I'll hand over now to the CEO of Dotlumen, Cornel Amarel. who will briefly talk about this
Thank you.
and demo his solution and possibly ask for a volunteer.
Thank you. And actually, let's start with that. Thank you also for the introduction. However, we do not make people see, just to clarify that, but we do guidance. We basically replicate what a guide dog for the visually impaired does. And I want to talk all about it, but before talking, I would love to have a volunteer who wants to test. Who wants to test? We have a volunteer over there. Right behind you, actually, is my colleague, who is ready. It almost seems staged, but it isn't. Okay, I'll give you a bit of context. Until my colleague helps the volunteer be trained, it takes roughly a couple of minutes. I want to give you a bit of context. So first of all, I was born in a family of people with disabilities. I'm the only person without a disability in my family. So growing up, I really see how much technology can help, but also how little technology exists. And today we have about 300 million people with visual impairment. But if you check what solutions they have for their mobility, the most used ones are still the white cane and, of course, the guide dog. And the guide dog for the visually impaired, it's a great solution. It does good what it does, but it has a couple of drawbacks. It's a lot of care, a lot of work to take care of, one. And two, if we check how much is being spent on training guide dogs, last year, €500 million was spent on training just 2,000 guide dogs. That makes the cost of a guide dog above €200,000. That is not a scalable solution. So what we said, hey, can we use technology to replicate what the guide dog is doing and more? So we took technology, we actually came from self-driving from the automotive world, and we took everything that a self-driving car is doing, and we put it into a headset which you can comfortably wear on your head. But if I will make an analogy with the guide dog works by pulling your hand, avoiding you from obstacles, taking you to your destination, outdoor or indoor. Our glasses do exactly the same, but they don't pull your hand, they're not on your hand. They actually pull your head. So we have this patented haptics, and you feel on your head how the system is guiding you towards where you can go, avoiding you from obstacles, taking you to your destination. Now we have tested with over 300 blind people from over 20 countries. This system is coming on the market beginning of next year. We're a team of 50 engineers and scientists coming from Romania, where we are based at this point. So I think the tutorial should be done pretty soon. It usually takes like a couple of minutes until you get the absolute basics of the system. But until then, just maybe to share a couple more things. For example, the first blind person in the world to go hiking on a completely unknown trail without knowing where they are, without having any kind of assistance, happened just like 9 months ago with our technology. The first blind person going shopping in a large supermarket with absolutely no assistance happened 2 years ago with our technology. And what you will see very, very soon, I can actually hear it in the back, it's what we have for basically the last 2 years. It's not the manufacturing version. It's a internal prototype from around about 2 years ago. So it's roughly half the size, roughly twice as big and twice as heavy as the manufacturing version. So when my colleague is ready, he can close his eyes if you don't have a blindfold for him. Maybe I can take 1 or 2 questions until everything is done with the tutorial. 30 seconds. 30 seconds for a question.
In the meantime, maybe you can tell us about the inspiration for the company.
Sure. I mean, definitely inspiration came from the family I was born in. I mean, everybody in my family, my parents, sister, nephew, cousins, all of them have disabilities ranging from visual, locomotive, mental disabilities. I'm the only person without a disability in my family. And after a career in the automotive world, spending time in autonomous driving, understanding how that can help in the road environment, we basically said, hey, I think we can use this technology for helping in other environments. So the underlying technology, what we invented here, we call it pedestrian autonomous driving, is the first general level navigation system which can actually do everything a self-driving car does, but on the pedestrian environment. So understanding the world in 3D, understanding where it is safe to move and not, path planning to take you to specific goals, and actually in the end representing the information. So I think we're gonna have a first test. You can see it in the back. Let's see, after 2 minutes of training?
Hello, it's great to meet you.
but you'll have to keep your eyes closed. If anybody has a scarf to blindfold him, that would be cool. But I wouldn't go in front of him because then the system will just turn him around. That would actually be cool. I think you can bring him to the front directly, so it's even better, so we can see him over here.
Just as we prepare this, just to let people know who are online, chat is open for questions.
Just to explain a bit what he feels, he basically feels the device pulling him in the direction where it is safe to go. Of course, I guess this is his first time in his life walking blindfolded, so
If I come here and block your path, what do you feel? Yeah, there's something here.
So does he feel something?
yeah. So he basically feels the device directing him in the direction where it is safe. Now, this is not an environment appropriate for the technology. It's mostly designed for outdoor. Outdoor, it would actually keep you on the sidewalk, help you understand there's a crossing, help you cross the crossing. You can actually go on Google Maps, find a destination, press share it to the glasses, and the glasses can take you there. Pretty soon, that will include public transport. You can be in one corner of the city and go directly to the other one, and the device will take you there, including public transport in the nearby future. You will ignore that hand because you can see it's a human. The device is narrow every time. There's a path less than, I think, 90 centimeters in width. So you'll basically hear narrow a lot here. It's a narrow place. You can keep your hands down. You can trust the technology. Let's take the blindfold off. Let's see if he knows. Thank you.
Thank you. Thank you to Cornell and our volunteer as well. Thank you. So I'll hand over now to Dr. Jose del Milan and his team to demonstrate a AI-controlled hand exoskeleton. Thank you.
Hello, I am pleased to share with you today one of our latest brain control devices. This is a brain control hand exoskeleton that it is intended for rehabilitation, how to provide people the possibility to recover motor function after a brain insult. It has two components. One is the hand exoskeleton that has been developed by my colleague, Dr. Ashish Deshpande. The hand exoskeleton has to provide very precise, repeatable movements, because this is essential for rehabilitation, to do many times the same movement so that the central nervous system understands that this is the movement that the subject wants to do. And this, when it is coupled to a brain-machine interface, that is what we develop in our lab, will provide two kind of things. One is enhancing plasticity, meaning that the brain will start discovering, rewiring the pathways that originally were damaged in order to discover others. And this repetition will tell this activity which is the way to go. But the other component is to have the commands generated in the brain of the subject, in particular around the areas that were damaged. Because one of the properties of our brain is that even if the hand control, it is normally represented in a very particular area, there are other areas that are also partially representing that movement. But this is not enough to generate the actual movement. So what the brain-machine interface does is to identify, to decode the intention to make a movement that the patient cannot execute. The brain-machine interface will be delivering the command to the hand exoskeleton that will execute. And now we will have two signals. One is descending, because there will be activity from these partial representations of the brain going down the spinal cord. This will not be sufficient. This will be matched by the ascending patterns of activity because of the movement, plus the fact that we are delivering a stimulation on the peripheral nerves that recreate the sense of movement. And these together will reinforce those patterns of connectivity. The latest innovation that we are presenting here is the fact that in the same way that we need a rehabilitation robot that does always the same movement, ideally we need the patient to do always the same kind of activity in the brain so that the two are coupled. This is quite difficult. What we do is to use novel algorithms that will take a model, eventually the model of a healthy person who has a very good control of the brain-machine interface, and match the data of the patient as the patient is using the brain-machine interface to that data, that model, so that immediately the person can have control enough to benefit from the rehabilitation. These days in the exhibition area, there have been visitors who have never tried a brain-machine interface, and after 2-3 minutes, they were capable to control the hand exoskeleton because they were using the model of one expert. So the two together is spreading this massive plasticity process and allowing people to have immediate control of a brain-machine interface. So now I pass the floor to Ruofan, one of our lab members, that will be demonstrating the fact that whenever he will be imagining the closing of the hand, the brain-machine interface will be decoding, activating the hand exoskeleton, and in some other occasions, we will be willing to stay at rest because it is equally important that we do movement whenever we want to do a movement as it is that we don't any movement when we don't want to do a movement. Otherwise, we will not be in control of our body. We will be Parkinsonians in a given sense. So, Ruofan, whenever you are ready. So Ruofan has an interface that will tell him when to do the closing, when to rest. You can see now the movement. We lost the connection. Okay, we have a problem with the wireless. The connection has been lost. Now it works. No. So Ruofan is using the model of somebody else, and the algorithm is adapting in real time to his brain signals. And something important to realize is that normally when someone is using the brain-computer interface, they are in a comfortable situation, either in the clinic or in the lab. Now Ruofan is in front of you. You are stressing him like hell. And normally his brain signals will be totally different to what we have observed before, and yet the algorithm is allowing him to rematch the original signals of the expert. If any of you want to try, we propose this game, that Ruofan will be controlling your hand. For that, all what you need to do is to lend us your arm. We will put some electrodes. These are the electrodes that will deliver currents to your peripheral nerves. And these electrodes will generate contractions of your muscles so that you move your hand. Actually, Ruofan will make your hand move for you.
Might I actually suggest, because we may run out of time, that we could do that just afterwards?
Yep, yeah,
Would
sure.
that be okay?
Whenever you are ready.
Thank you very much for that. So Dr. Jose and his team will be demonstrating afterwards, but also there will be a workshop afterwards as well, and we'll be in the exhibition area as well. So I'd like to turn now to our penultimate presentation and demonstration from the team at Inclusive Brains, if I may. And then we'll do one more demonstration from Cognixion, and we'll open to questions.
Thanks a lot. With Paul Barbas, my co-founder, we have one observation that we should all be making, is we spend our days adapting to machines, and it should be the other way around. Machines should adapt to people. Machines, artificial intelligence, AI models, you name it, they're just here to serve us, to assist us. And every one of us, regardless of our abilities, of our needs, our physicality, however special this might be. Based on that, we observed that the entire world is super excited about generative AI being able to recreate language and words. But there is so much than words when we look at the way we interact as humans. Look, I'm from the Mediterranean, so I use my hands a lot. But there is what you feel, the emotions, what you sense. So in order to empower machines to adapt to people, we started from the get-go to train our AI agents with brainwaves, facial expression, eye tracking, so eye movements, prosody, so the intonation of a voice, the vocal stress. You can hear a lot of things in the voice, including when we smile and when we speak. Heartbeats, physiology. This is called multimodal AI. The goal is really for devices, connected devices and digital environment to function as close as possible in terms of learning, adaptiveness, and predictive power as the human brain. Amongst the things that we do also is to empower machines to be controlled without the need to touch, without the need to talk, without the need to move, because there are millions of people out there who cannot use their hands. And because they cannot use their hands, their limbs, or their voice, they are entirely excluded from the workforce and from education. What we're going to demonstrate is Prometheus BCI, a partnership between Inclusive Brains, our company based in Marseille, France, and Allianz Trade, the world leader in credit insurance, that basically leverages the combination of generative AI, multimodal generative AI, and brain-machine interface in order to help people who do not have access to work be able to control machines. And what Paul is going to demonstrate is something that happened at the beginning of the month in Marseille, France, during the Olympic torch relay. We met a wonderful lady called Nathalie. Nathalie is not only living with a motor disability, she also has cognitive impairment. In our previous lives, we helped Rodrigo Ubna Mendes, a person from Brazil who's quadriplegic, to mind control a Formula One, a real Formula One on a real racetrack. But Rodrigo was paralyzed from the neck down, but he could focus and use mind control, mental commands. Nathalie, unfortunately, cannot, because she cannot focus. But Nathalie can do two things that are amazing, on demand, and that she controls. She can blow a kiss, so she can do, and she can open her mouth and give a wonderful smile to show that she is happy. And when we met Nathalie with Paul, our usual mental command algorithms wouldn't work with her. So just like a tailor, we tailored the solution to her by creating a combination of her brainwaves, her facial expressions, and her muscles, facial muscles, to empower her to mind control Prometheus BCI, this exoskeleton arm that will be given after the Olympics to organizations, non-profit organizations that support disability. We will also put the mental command algorithms open source, and this is thanks to our partnership with Allianz Trade. So Paul, I think it's time for you to give a little demonstration of this technology that really combines what is happening on his face, what is happening in his brain, and what is happening in his facial muscles, the way Nathalie experienced it.
Okay, hands off.
I'm excited for our conversation.
Again?
Could you tell me more about the technology you're excited to discuss?
Well, now let's go down. Stop.
One more?
Okay, let's go up.
No, down?
Sure. Up. And down. This is the way things should be. Leveraging tech in order to adapt tech to the needs of people and to be able not only to help them achieve simple actions for most of us, but also to use this technology for other purposes. In order for this to happen, we had to develop algorithms and models that picked up attention, stress, cognitive load, and fatigue very quickly to minimize the calibration time, to minimize the learning time. And these are little AI agents that we can use beyond our work with people with disability and special needs. They can help in the workforce in order to make sure that AI and neurotechnology are employed in order to preserve people's health, mental and physical. And this is what is at the core of a partnership with Allianz Trade. The fact that we're helping people with disability in order then to help the entire world, based on a fantastic innovation that Paul and I love, the remote control, which was invented to help people with disability change the channels on their TV sets and then change the way all of us interact with technology, billions of us, and which leads to my last point. This is not a charity. Assistive technology is not a charity business. It's a business that can scale, that not only does the good that we need to do, but also can be profitable. And we got great examples around here, and we have to give a props to our fellow French company, Wondercraft, who have been an inspiration from day one, doing AI and robotics for good. And you're going to see what Andreas is doing. I mean, Lumen is fantastic. We love seeing the fact that this technology is helping people, but also being profitable at the same time. And if we may have a few more seconds, this morning on stage, Paul, only with the power of his mind, sent a tweet about what we were doing. And the tweet was sent to President Macron. And President Macron was very kind enough to reply to us. So I know you might think that we're Frenchmen, so we don't have to be polite, but we are polite French people. So we have to thank President Macron. And Paul, if you can have a look by coming behind, Paul is going to send right now live our reply to thank President Macron for his support, and of course mentioning that all of this happened in this incredible event. Thank you, ITU. Thank you, the United Nations. If you want to come, just so. Paul is using a combination of his head movement and his brainwaves. So he can choose the letter with his head, and then he's clicking with his mind in order to gain some speed. So at the moment, you asked what President Macron said. He congratulated us for the work we've achieved, knowing also, and that is important in saying that it's AI for good, that we're a small company with 4 people only, and we've been doing incredible things with very limited resources, showing that we can achieve great things that help people and that it doesn't require tens and tens of millions. Yet we're going to raise a big amount of money in order to scale very soon. But everyone can start and help and leverage AI for good for people with special needs.
Thank you, Olivier.
Oh, he can focus. I'm going to share the video afterwards.
So while he finishes that off, I'm going to briefly introduce our last presenter from Cognixion, who is right at the end. And then we can open to questions. So over to you.
Thank you, Chris. Can you hear me okay? I'm going to stand up. So my name is Andreas Forsland. I'm the founder and CEO of Cognixion. We're based in Santa Barbara, California. We have an R&D center in Toronto, Ontario. What I'm sharing here today with you is a product we're launching now. We're launching it this week. Internationally, it will be available in the fall. It's available currently for sale in the US and Canada. The product is called Axon R. It's a fully integrated brain-computer interface with augmented reality. So it's one complete system. So I can actually see each of you through the lens. This is a tinted lens for light contrast, but it projects holograms on the inside. And this system here is called the nucleus. It's a neural hub. And so you see sensors on the back of my head. These are brain sensors using EEG. So what it's doing is it's processing the data of what I look at through the visual cortex of the brain. And so like many of our peers here, we're trying to help people with very personalized needs to be able to access computers and do things. So for us, we've been testing our technology with individuals that are traumatically locked in. We're working with hospitals such as Northwell Health and Memorial Hermann in the United States within their neurology practices for disorders of consciousness or individuals that are in completely vegetative state. To be able to interact or try to understand how they can interact with the world around them when they can't even move their eyes. So our goal is really to develop a modality that is the sense of last resort for millions of people. This can be used in hospitals, it can be used at home, it can be used also on the go. It's 5G capable, so life doesn't sort of start and finish at home. Life goes beyond the walls of our house or the lab. This product specifically, what I'm going to be demonstrating, this product is designed for researchers, clinical and scientific and academic researchers. It comes with an SDK to build your own applications. I'm going to show you an AI-generated application that's running in the headset. Right now what I see are holograms. And so my communication partner here is going to help me demonstrate some things. So she is, her name is Elizabeth, and she is going to ask me some questions via her chat application. Her chat application will present her transcribed caption in my visor, and my personalized sort of digital twin of myself will suggest responses within the headset, so I can simply use my mind to select which is the appropriate sentence. I can also turn the conversation, so it's not just an interrogation, it's also something I can actually sort of pivot and sort of shift by asking my own questions and sort of drive the conversation. So we're, in the short time that we have, we'll try and get a couple of turns taken here so you can see the possibilities of what you could build on a tool like Axon R. Hold on, I'm going to clear something really quick here. Go ahead.
Hi, Andreas. Can you tell me about cognition and what is special about your technology?
And so I see what she just said, captioned. So she could be communicating with me from anywhere. She could be in the house, in another room. She could be asking me, what do I want for dinner? But in this case, she's asking me about the company. And you hear the tones. The tone is giving me biofeedback and neural feedback based on what I'm actually interacting with, so that it can help me learn you know, more of this, less of that as I'm interacting with objects using my mind. It also tells other people around me that I'm working when I can't speak. That tells you that I confirmed a selection. I'm going to refine it. I can also adjust the tone, so I can make it more positive, I can simplify it, I can add sort of flavor to it if I want to be spicy. In this case, I'll be pretty straight.
Cognixon is a remarkable company that creates assistive technology.
So that was entirely using my brain, no muscles. It's paying attention to what I'm paying attention to. So I can actually monitor what I'm intentionally paying attention to, and I can also train my mind to deselect or avoid things. It's called overt and covert attention. And so we can monitor and measure that level of brain activity through the visual cortex. And so you can imagine an individual who has, say, late-stage ALS or others who their eyes, their ocular motor doesn't work so well, and they have very trouble time sort of using eye tracking. Eye tracking tends to fail in later stages of disease progression. So this kind of technology would allow someone to look straight ahead, and we can monitor what happens in the peripheral vision so that you can actually select things that's within your broader field of view using just your mind. So it has tremendous applications for accessibility, especially for the most vulnerable. It also has practical use cases for many different kinds of healthcare applications. So we can measure the latency of the sort of photon as it goes through the retina, through the optic nerve, and those are, you can measure aging, brain aging through the visual cortex, such as neurodegenerative conditions can be measured through just the time latency. There's also emerging science around therapeutics for dementia and Alzheimer's, for 40 hertz light therapy that can be implemented within the visual field to help with memory care and reduction in amyloid plaques. So there's a tremendous amount of opportunity and breadth beyond just assistive technology. We see assistive technology as sort of the tip of the spear in the spirit of what's called universal design. So by designing for the most vulnerable, we actually help all of us. But as a platform, we think that this could also be a real disruptive technology for creating new opportunities in advancing healthcare, ranging from assessments and diagnostics and therapeutics. It has 5G so that you could actually have remote telehealth and neural monitoring. So we're very excited about Axon R. We're very excited about brain-computer interface, augmented reality, AI. We're also very excited to be sharing the table with these wonderful people also working to solve AI for good. Thank you.
Thank you. So we're a little over time, but can I open to questions from the floor for our speakers? And there is a microphone. Yes, over there.
Hello, thank you for your presentations. Yes, I will do. Kazmira Jefford from Geneva Solutions. Just a question to any of you that like to take this. A lot of the conversations that take place in Geneva are about the ethical implications of some of these technologies. Could you speak to some of the risks that your technology, you've talked about how they can be harnessed for good, but what could happen if your technologies were used for bad purposes, and what scope do they have for being hacked or, exploited for other reasons?
In our case, essentially, we're creating a separate channel of communication. So the same way that you're selecting what you put into verbal mode, so what you speak, which is independent of thinking, is the same here, right? So we're not reading people's thoughts. We're just creating an easy way for them to express themselves using specific biosignals. So from that perspective, the privacy issue is bypassed, so we don't see that. Obviously, there's always possibilities, for insecurity in different devices, which is why we take security very seriously. But so far, that's been one of the biggest questions, and in our particular case, it isn't an issue. And from what I've seen, probably not in yours either.
I'd say, Andreas here at Cognition, I'd say our perspective is that we started the company 10 years ago, so we've been spending a lot of time thinking about this and working with patients, and we have a user advisory council of over 200 people with severe disabilities that give us actual lived experience and feedback on these types of things, and there's always trade-offs around data and privacy. The utility of these kinds of technologies outweighs any kind of risk of privacy data for vulnerable people who would get great benefit from these technologies. We've sort of always tried to design for what we call the offline first experience. So as much compute that has to happen on device as possible with the least amount of dependencies on cloud or network, because it's in the transition of data over the air where you are the most vulnerable. And so what we're trying to do is focus our architecture so that the core technology of the main utility can run on device with no dependencies. But if you want to open it up to large models that are in the cloud or edge computing, that's a voluntary thing that the user or the user's caregiver would opt in for. And they know what that consent would look like as far as vulnerability.
Thank you. Did I have a question over here?
Thank you very much. My question is for Mr. It's Maya Plants from the UN Brief. I would like to ask Mr. Prado about you mentioned that you just made an agreement, a licensing agreement or partnership with OpenAI. If you can talk a little bit about that.
OpenAI has a number of initiatives trying to leverage part of their technology for initiatives they consider that are positive. And we have a partnership to be able to access some of their models that are not publicly available in this case the voice LLM, to use in this particular application. That's pretty much it. There's no more financial gain on either side. It's just they're trying to do something good, and so are we, and there was a synergy that we felt that had benefit.
So it's more like a research project?
No, I mean, so once this goes commercial, then we would basically be paying for access to the LLM, but we have access to LLMs that are not available yet, or that are more restricted because they need to have specific applications. As you could see with the voice LLM is scary good, right? I mean, like Paulo's voice, you don't know him personally, but actually sounds exactly like him, right? And so it needs to be monitored and used carefully in how we use it. And so for us, I mean, for ALS patients, obviously it's magical to get their voice back. So it's a very worthwhile use of this model, but I can see how the hesitation in releasing it generally.
Also mentioned the multilingual challenge. I was going to say that, yeah, there's also a challenge in terms of multilinguality, okay? Because, for example, kind of the cloning of my voice in Portuguese sometimes comes up as Brazilian, sounding like Brazilian Portuguese, and so we're going to partner on that also, because these kind of models are biased towards certain languages, and so this is a challenge that we have to face also, and so the collaboration is both ways. So, and Babel is also going to.
Thank you. I think we have a question from John. We can have the microphone.
John Halpern, Arete News. Just a quick question. I'm just wondering if any of you can address what you're doing or how difficult it is to address social biases, reduce discrimination and inequality, to make your technology as inclusive as possible.
Well, this is an excellent question. When you come to the field of assistive technologies, when you come to the field of health, and in this case, rehabilitation, we are in a given sense out of control, especially for rehabilitation, because that depends on the health system who will be paying on behalf of the patients. So what we want is to make a technology that eventually patients can take home. It will not be exactly this one. This is intended for the hospital. But if we can make the technology in such a way that people can take it home, we will be reducing the cost, and some of these fellows are showing that, so that we will be reducing the cost of the rehabilitation so that it will be beneficial for the system to accept those kind of interventions.
Thank you. Any other perspectives from our speakers?
Our job is very often heartbreaking because we give hope and sometimes we help people who are excluded from society to achieve certain things, being driving a Formula One car or world premiere of the Olympic torch. And then I had recently a mom who came and said, "Can you do something for my son who cannot hear?" And my answer was no. So in that sense, we're not very inclusive. But do we have to stop because we cannot help everyone? No, I think that by advancing what we do with Inclusive Brains, what everyone does here, we're covering certain areas. It's at the same time extremely rewarding and heartbreaking not to be able to help people, to provide assistance. And we hear a lot of comments and questions like that, sometimes very kind, sometimes not very kind. We're doing our best, and as usual, the best is not enough, so we're going to do more.
Thank you. So I think we have time for one or two questions, and then we probably need to finish. We're 15 minutes over.
Boris Engelson, a local freelancer. I would have a lot of questions, but I think we can ask them subsequently. So I will just have one to Mr. David Hirsch. Here today at the press conference, we have focused on robots and robots as aids for crippled people. But AI for Good has several aspects: robotics, SDGs, things about information discussed in workshops. So robots we could see at a robotic show. What is the added value of ITU and AI for Good to the whole issue, considering that robots we could as well see at a robotic show?
Thank you. One of the things that ITU certainly brings to this and to all of our forums is the convening power of International Telecommunication Union as a multi-stakeholder focused specialized agency of the United Nations. And what I'd like to do, maybe, if I can, I have behind you Fred Werner, who's with the AI for Good team. I don't know if you want to pick up on the question, but one of the things that I would say is that when we make a decision relative to showcasing technology, there is, as you know, on the display floor and in the participants, there's a variety of technology that's on display in this conference. But for an event like this, certainly, it's nice to be able to focus on one element, and it's certainly nice to be able to see the value that this technology is providing to people's lives, and certainly how it's helping to advance the SDGs, which is, as you know, the primary focus of the AI for Good program. Fred, I don't know if you want to add to that, but.
Yes, thank you, David. Yes, I'm Fred Werner, organizer of AI for Good. I mean, one of the goals of the summit is to introduce the world to new technologies, new frontiers, and to demonstrate the capabilities and limitations of those technologies. And everything we do, whether it's our programming on stage, our debates, our keynotes, our exhibits, it's all mapped to the SDGs. So, and that's the goal of the summit. So really, you know, if you go to a big robotics conference, you'll see a lot of industrial robots, commercial robots, fun robots, but all the solutions here really are picked because of their impact on the SDGs, and I think we demonstrated that here today because it's really changing people's lives. We've been doing AI for Good for 7 years, and I think today was the best example I've seen of AI for Good, helping people to regain their mobility, their sight, their hearing, their communication in a way that was never possible just a few years ago. And if you look at the devices today, it reminds me of the mobile phone in maybe the early 90s or the 80s. A bit big, clunky, it worked, but it didn't take long to get the iPhone. So just think about how long it will take before these are really mass deployed, helping people regain their mobility. And then what we're looking at the future is, you know, going beyond that, how can this help people with mental health, with human performance? Upstairs, we have this one skeleton that can actually, you know, it's not like this really for the extreme cases, but helping people maybe, you know, the elderly who can't quite go upstairs or would like to go for a hike to add a few extra horsepower to move along. I mean, these are amazing examples. And then also there are other examples where, you know, you wouldn't want to send a human into many situations like a fire or a nuclear meltdown or into maybe a cave that's about to crumble. So upstairs there are quite a few demonstrations of robotics for natural disaster management and also use cases for like agriculture, obviously medicine, productivity tools. So yeah, I think this is basically the best example of AI for Good I can think of, but underlying that is really the SDGs. Without the SDGs, you know, people are flying blind, you know, so at least we have a common framework and agreement of what direction to go in.
Thank you, Fred. I also have a potential answer from Olivier to your question, Boris, so over to you, Olivier.
We heard from the organizers, so as a guest here, I have to respectfully disagree with you, sir. This is not a robotics demonstration or press conference. We're talking about the outcomes, about how we change the world, or the little micro steps we're doing in order to improve the lives of people, be it with hardware agnostic solutions that we're doing with Paul. Here we're working with an exoskeleton, but actually our solution will be uploaded to any connected device or virtual environment. You see what Lumen is doing. I didn't see any robot here. I saw humans in action, and I saw great advances. And I could speak about every company here, about their outcomes. And I really hope that one day people will stop asking us about what we do in terms of technology and focus on outcome. If I were a carpenter, I wouldn't be talking about my hammer. I would be talking about what I built. And I think what we built is much more important than robotics or AI.
Thank you. So unless there are any other questions, I think we're going to close now. So any further questions? Well, thank you all for attending, and thank you all for listening so assiduously, and thank you also to our great speakers and our demonstrators today, who will probably be findable upstairs in the exhibition areas if you want to kind of carry on conversations. So thank you all very much. Have a great afternoon.
Thanks.